So let us start where we left. So the definition of the material property has been done for the concrete and steel bars. Now we have to move towards the definition of the section properties for column, beam, slabs, and structure walls as per ACI 31814. This is part 3. First of all, the column, there is no such limitation on size of the column. As long as you provide minimum reinforcement, you can select any size of the column and check it for your due on demand. For the reference, you can also visit the ACI 314 for chapter number 10, section 10.3, where it explained it very well that there is no limitation on the size of the column, as long as you provide the minimum reinforcement of 1% in the column, right? So you can select your desired section and you can check it for the given demand. So let us go to the define section properties, frame section, and let us delete all of the unnecessary sections. Let's now click on the add new property. A window will appear. It's asking, giving you information about the quick templates that has been defined in ETABS, but you can select your desired section from a drop down menu. So now we have this quick templates concrete rectangular. So we will click on this. So we can name it as a, we have architectural column 24 plus 24. But on first of all, you have to check this column. But when you have enough experience in design, you will directly select that section of the column that will fulfill the required criteria of your structure. So now we have 14-story building. So let us select, and we have grade 2040. So we will select 36 cross 36 inch column. So when you do that in your model and you check that it is working in at 36 or 36, so you have to change in architectural drawings and send back that architectural drawings to architect that we have changed the dimension of these columns. Please check it, right? So in this way, you interact with the architect time to time. So you will select 6,000 PSI concrete strength, right? And this is the section rectangular. You will add here the width and depth of the concrete. So this is the dimension of the column. So now there's a property modifiers in here. So I'm not going to use this because there is a slide in PowerPoint. So after explaining this, we will again come here and modify it, that what is it and why we use this stiffness modifier. So we'll click on the reinforcement modifier, show rebar. So there is a new window which is asking about the design type, whether it is column or beam. So we will select this is column, and we will select that rebar we are using grade 60 steel. And this is the check where you want to design the your column you want to check or design. If you want to design our column, so this is keep this by default and click on OK. So this property has been defined and click on OK. Again, you can take the copy from this, click on that and add copy of the property. And we will define another section that is C 30 inches plus 30 inches. And again, we will select this 6,000 PSI and we will change this property into 30 inches, right? So you can verify whether it is selected as a column or beam. Click on OK. So two properties has been defined for the columns. So there is no restriction on the size of the column as long as you provide the minimum reinforcement and the column fulfill your design demand. So this was definition of the column as per the ACI, that there is no restriction. The next one is the beam. Initially, the depth of the beam should be calculated as per ACI 1314, table 9.3.11. And what does it say? It's saying that the minimum depth of the non-prestressed beams, right? So there are conditions that for the minimum H, for the simply supported beam, L by 16, L is the clear length. And if the one end is continuous and other end is dead, it is L by 1, L by 18.5. And if both ends are continuous, it will be L by 21. And it is cantilever, it is L by 3, right? So we will select our region if we want to calculate the depth of the beam. So we will select this one. We will say that we want to calculate the depth of this beam, that is this end is dead and this end is continuous, because this beam is continuous from these 3 base and so on. So this end is dead and this is continuous. You can also select this one. For this beam, both of the ends are continuous, right? So you can see if you select both ends continuous, it will give you less value. But if you select both ends, one end continuous, it will give you more value, right? Let us check. We will select this one. This is 19 feet. So we will have 19 divided by. So we will be doing this on hand calculations. This is one end continuous 18.5. So we will divide this 18.5. So it's giving you the value in feet. So multiply that in 12. So 12.3 feet, 12.3 inches is the minimum depth of the beam for this panel, right? If you use this one for 20, that is continuous in both ends, that will be 20 divided by 21 into 12. So let us do that. That is 20 divided by 21 and multiply that into 12. So it's giving me the value of 11.4 inches, which is less than this 12. So we will go on the conservative side, we will select 12 inches. That is the minimum depth. So we will not be selecting 12 inches, which is the minimum depth requirement. We will select our beam depth 24 inches, just to incorporate the serviceability requirements of the ACI code as well. So there is no restriction on the width of the beam. You can select any width according to your requirement. You can select 12 cross 24, 14 cross 24, 15 cross 24, or any other combination with the depth, but we will be using 12 cross 24 combination in this model. So we will again go to add new property, click on the complete rectangular section, and we will name it B 12 cross 24 inches, and we will select 3000 because we will be using 3000 psi in slab. So slab and beam are constructed monolithically, so same property should be used in the beam as well. So the depth is 24 inches and the width is 12. And go to the reinforcement, modify rebar, and click on this, that is only designed for beam. And the property is grade 60. We'll click on OK. So the beam property has been defined as B 12 cross 24 and 2 properties of the column. So click on OK. So now the beam requirement has been fulfilled according to ACI code. Next one is the walls. Minimum thickness of the wall should be calculated as per ACI 31814. This is table 11.3.11. So these are the different conditions for the walls. If it is bearing wall, if it is taking flexure loads as well as shear walls. If it is non-bearing walls, for example, it's just a partition wall. If you are constructing an RC wall just for partition, so you will using this. If it is taking loads, so you will this condition. In our case, this is exterior basement and foundation. For the retaining wall, this is the condition, and it is straightforward that it should not be less than 7.5 inches. This is the requirement for the one layer. If you are using your wall thickness 7.5 inches, you can only place one layer reinforcement in that. So that is the minimum reinforcement. The minimum wall thickness is 7.5 inches. So we will take our wall thickness greater than 7.5 inches. And for the bearing, we have lift walls which will bear the flexure demand and bending moment as well as the lift walls load as well. So it's have two condition, 4 inches and 1 by 24 lesser of the unsupported length and unsupported height. It means that if there is no slab connected to this lift, there is no columns, there is no beam connected to this. So it's asking about that unsupported length and unsupported height. So if that condition applies on your structure, you have to go towards the this condition. But there is no condition, such condition in our model. So we have minimum thickness of 4 inches for lift wall and minimum thickness of basement wall is 7.5. So in our model, we will select our thickness for the basement wall 12 inches, right, to place two layers, because if you select 9 inches, 7.5 inches, you cannot place 2 layer of reinforcement in that thickness of the wall. So for the lift wall, we will select 15 inches because it will fulfill different criteria, and we will design it very well. And for the basement wall, we will select just 12 inches. So let us go to the ETAB. We will go to define, section properties, and wall sections. We will add new property and we will name it as and we will use, initially we will use 3000, and then this is modeling type shell thin, shell thick, and membrane. Shell thin, if you are designing your wall is very thin, for example up to 12 inches, 15 inches, 18 inches. But if it is very thick wall, for example in dams or in other structures, so you can select thick. In thin wall, it does not incorporate, the tape does not incorporate the shade deformation, but in shell thick it incorporate the shade deformation as well. So you will define the thickness, that's 12 inches, and we will click on OK. Again, we will define the lift wall. We will just 15 inches, and we will select, you will give the property to the lift wall same as you are giving to the walls columns. And the wall, the retaining wall can also be constructed with the parallel to the column properties, but it can also be constructed in FC prime 3000. So we will select 6000 psi and we will shell thin, and that will be 15 inches. Click on OK. So the wall property for the lift and the retaining wall has been defined. Click on OK. So this was the whole story about the wall thicknesses as per the ACI 3 coding. We haven't violated the limits of the ACI. So let us go towards the next part, that is the slab. The slab thickness is a bit tricky because we have two-way slab. If you go to the ACI code and go to the one-way slab, so the calculation for the one-way slab thickness is very easy, just like the beams. This is the minimum thickness requirement for the solid non-pre-stressed one-way slab, which has the condition only for length, span length. That is the unsupported length, that is unsupported, simply supported, one end continues both ends. So L by 20, L by 24. This is a very simple calculation. But for two-way slab, it is a bit tricky, right? So this is the section 8.3.1.2. This is the minimum thickness of non-pre-stressed two-way slab with beam spacing between supports on all sides. So there are three conditions. That is, let me increase this. So the first condition is alpha FM is less than or equal to 0.2. 8.3.1.2 implies that is the condition for the non-flat plate and flat plate, flat slab and flat plate system. So that condition will be used. But if the alpha value is between 0.2 and 2 alpha FM, so this value should be calculated, and that will be greater of this 5 inches and this calculations. And if the alpha value is greater than 2, so the greater of this will be selected as a minimum thickness, which is 3.5, or the value coming from this. What is alpha FM? Is the average value of alpha F for all beams on edge of parallel, and alpha FM will be calculated in accordance with this section. So on the right side, this is the section to calculate the alpha F, that is the rigidity of the beam divided by rigidity of the slab. And this is in the shorter direction, longer direction divided by shorter direction. This ratio should be in the range of 0.2 and 5. So you will find out this ratio and will compare, come to this table, and you will select your desired minimum thickness. ln is the clear span length in the long direction, and beta is the ratio of the clear span, which is the longer span divided by shorter span, which we used to define the one-way slab and two-way slab. So it requires a lot of calculations, and you have to be very careful using these equations. So let us go to this, and this is the Excel sheet I have developed for the calculation of the two-way slab minimum thickness. In this calculation, if you have noticed that this alpha is consisting IS. IS is the moment of inertia for the slab, which will have the dimension of the slab, the thickness of the slab, and the width of that slab in that desired direction, right? So initially you have to assume a thickness for the slab, and we will check it whether it is okay or not. So in this Excel sheet, you have to insert the data. This is in the green boxes. You have to enter the 3000 and then 6000, and you have to select the maximum span. We will go to the maximum span we are having is this. This is 20 in this direction and 15 in other direction. So in longer direction, we have 20, and shorter direction, we have 15. The other calculation will be done by Excel sheet. So we have alpha FM equal to 1.33, right? So now we will go to the table. Say alpha 33 is less than 2, right? And greater than 0.2. So this condition applies in our model, right? So that the minimum thickness is 5 inch, and this is this equation, right? Before doing that, we have to insert the dimension of the beam, that is 12 and 24. And we have assume, let's assume that we select 6 inches, right? So these values will modify. So our case is this one. This is our case. So finally, the value is 6.06, which is equal to our assumed value, right? So one condition is 5, and we have used this calculation. This is the formula used for the calculation of the other. So we have 6.06, which is equal to our assumed slab thickness, 6 inches, right? So the slab thickness for our structure is 6 inches. You can develop your own Excel sheet using these formulas, right? I have used these formulas to calculate the slab thickness. At first, you have to assume the slab thickness, and then you have to compare with the calculated one whether it is greater. If this value is 7 or 8, you have to select that. If this value is 5 or 6, then you have to select that one, or as per your requirement. Now we have to go to the define section properties, slab section, and you have to add new property. Let us call it slab 6 inches, and you will select the properties of 3000 psi. The slab, it is dropped, whether it is ripped, you can select that. You enter 6 inches, and you click on OK. So this is how you define this thickness and calculate the thickness of the slab using ACI 31814. So normally, I think most of you will be familiar with the perimeter formula that we normally is using. For example, if there is formula that is 12 into the longer side, L one side plus LB other side, and divided by 180. This is the formula normally used by undergraduate student to calculate the thickness of the two-way slab, but the actual calculation is done using these equations. You can also verify using the perimeter equation. For example, this is this is 2, not 12. So we will multiply 2 into 15 plus 20, and we will divide that by 180, right? So you can see by using the perimeter formula, it is giving the minimum value of the slab is 4.6. But using the actual formulas, it is asking you to give the minimum thickness of 6 inches, right? So if you are using up till now the perimeter formula, so that is not correct. So you can use this formula to find the correct thickness of your slab, right? So this is what the whole story about the slab thickness. Now, the last topic of this session is the stiffness modifiers. In numerical models, stiffness reduction factors shall be applied according to ACI code. This is the table. This is because to incorporate the effect of cracking of concrete during the linear elastic analysis. So we are using linear elastic analysis for our design. So in reality, what happens that the structural members cracks. So to incorporate that cracking in our numerical models, ACI recommends you to use these stiffness modifier in your model to ensure that in reality, that crack does not appear in your structure, right? So this is the table in which we have different structural members and the different conditions. For the columns, the moment of inertia should be reduced 30%. So we have to give the stiffness modifiers 0.7 into IG, right? For the walls, we have two conditions. If you want your walls to be uncracked during its lifetime or during your design, so give it 0.7 IG. If you want your walls to crack or behave as a crack member, so give it at 0.35 IG. It means that 65% of the capacity has been lost by the wall. The next one is the beam, that is 0.35 IG. It means only 35% of the stiffness has been remained in the beam and 65% has been lost due to cracking of the beam. And the last one is the flat plate and flat slab, right? So there is no stiffness modifier defined for the two-way or one-way slab resting on the beams. So we will define these stiffness modifiers in our model. So let us go to the define section properties frame section and go to the column 36, click on modify show property and click on this property modifiers. So this is the modifiers only defined for the moment of inertia about 2 axis and 3 axis. So we will define it 0.37 and 0.7, right? So this is the condition that defined by the ACI. So we applied it in the software. We click on OK. For the next column as well, we will use the stiffness modifiers for the moment of inertia. Reduce it 30%. So now we have reduced this stiffness of the column by 30%. Now what is the value for the beams is 0.35 IG, and you will go to the beam, modify its property, and click on the property modifiers, and again 0.35 and 0.35. Click on OK. What will happen if you do not use these stiffness modifiers? That the software will design your structural members on 100% capacity of this of the member. But in reality, what will happen that small cracks will appear in your structure, and you will be confused when that I have modeled it in ETABS and it was giving very satisfied results because you didn't use these stiffness modifiers. You didn't incorporate the cracking of the concrete using numerical models. So for walls, we want our walls to remain cracked during our design process. So we'll use 0.35 IG, but we do not have any flat plate, so this is not usable in here. So we click on OK. We'll go to define section, wall properties, lift walls, modify, and here is the modifiers current default. Click on OK, and we will want only bending to be 35. Click click on OK. Same for the retaining wall. This is how you define your sections and assign them stiffness modifier. There is another option as well in ETAB where if you have forgot to modify your stiffnesses in your structural members, there is another option. You select that member. But let me show all of these. Select that member and you go to assign frame, and here is the property modifiers. So you can assign your modifier properties as well in this 3D model as well, right? If you forgot to insert that modifiers in the section, your definition of your section. This was the whole story. So I hope this was very helpful for you to define different type of structural member sections and property materials as per ACI 31840. So if there are any questions, you can ask.
सर वी यूज टॉर्जन, जो हम यूज करते हैं वो टॉर्जन के लिए बीम में 0.01 वो हम लेते हैं, तो अभी इसमें भी हम लेंगे या नहीं?
आप ACI कोड यूज करें, वो 0.01 इज नॉट रिकमेंडेड बाय ACI, वो यूरो कोड ने रिकमेंड किया। अगर आप यूरो कोड यूज करें तो फिर आप वो यूज कर सकते हैं। ACI में
तो
ऐसा
सर
कुछ
इस
नहीं है।
जी, तो उसको जो है ना टॉर्जन में हम सब सर वो 1 लेते हैं।
हाँ, ACI ने तो फिलहाल 1 लिया है। अगर आप नॉर्मली डिजाइनर्स यूज करते हैं 0.1 यूज करते हैं, या कुछ डिजाइनर 0.01 यूज करते हैं, तो आप यूज कर सकते हैं, ऐसा कोई नहीं है। लेकिन वो सिर्फ यूरो कोड में डिफाइन है, ACI में डिफाइन नहीं है।
सर वो जो फिर इसके जो टॉर्जन है बीम का, तो वो तो रिइंफोर्समेंट भी इसकी लगेगी ना बीम में?
देखिए, बीम
मैंने
डिजाइन
कई
दो किस्म तरह की होती है। अगर आप उसकी ग्रेविटी के लिए डिजाइन कर रहे हैं तो आप उसमें टॉर्जन को इंक्लूड करेंगे, लेकिन अगर आप बीम को अर्थक्वेक के लिए डिजाइन करें तो आप उसमें टॉर्जन को नो करेंगे। लेकिन अगर आप
तो फिर
दोनों के
हम
डिजाइन कर रहे हैं, टॉर्जन के लिए भी कर रहे हो, आप ग्रेविटी भी कर रहे हो, उसमें आप टॉर्जन भी ले रहे हैं, तो फिर आप स्टिफनेस मॉडिफायर फॉर द टॉर्जन आप फिर 0.01 यूज करेंगे या 0.001 यूज करेंगे।
सर अगर हम बीम में जो है ना वो टार्जन 0.01 या 0.1 लेते हैं, तो वो टार्जन तो कॉलम में फिर वो ट्रांसफर होंगे ना, तो वो कॉलम फिर लेंगे।
हाँ ना, अगर आप एक सेक्शन में आप मॉडिफायर, ये हमने जो मॉडिफायर मॉडिफाई किए, तो इसका मतलब ये कि कॉलम आपका जो बीम है उसकी स्टिफनेस बहुत कम है टू टेक द बेंडिंग, तो वो सारा बेंडिंग कॉलम ले लेगा क्योंकि उसकी स्टिफनेस ज्यादा है। अगर आप बीम की टॉर्जन कम कर लेते तो वो स्लैब में ट्रांसफर कर लेता है या कॉलम में ट्रांसफर कर लेता है।
चलो ठीक है सर, थैंक यू सर।
अच्छा सर, ये आपने जो मॉडलिंग में बताया कि 1 स्लैब सिलेक्ट या ऑल स्लैब सिलेक्ट, तो ये 3D में करते हैं किस तरह, वो कौन सा ऑप्शन है यूज करते हैं?
मुझे समझ नहीं आया, काइंडली तेज बोलेगा।
सर आपने जो स्लैब सिलेक्ट किए थे, सर आपने जो स्लैब सिलेक्ट किए थे ना, 1 स्लैब सिलेक्ट या ओवरऑल स्लैब सिलेक्ट, ये कौन से ऑप्शन से करते हैं मॉडल में?
स्लैब की डेप्थ की बात कर रहे हैं कि बीम की डेप्थ की बात कर रहे हैं?
ये सर स्लैब की
सर,
बात
जो
करते हैं
आप
कि
मॉडल
मतलब
में एक स्लैब सिलेक्शन की बात करते हैं।
ETABS में सर जो
सर
असाइन
उस
करते
पर
हैं ना
आप
सेक्शन, वहां बात कर रहे हैं सर।
आपकी आवाज बहुत कम आ रही है, मुझे समझ नहीं आ रही क्या कह रहे
हाँ
हैं।
सर, मैं ये कह रहा हूँ, आप शुरू में जो कर रहे थे मॉडलिंग, उसमें आपने जो लेफ्ट वॉल वगैरह और शेयर वॉल के लिए आप कर रहे थे कि पूरा 14 स्टोरी सिलेक्ट करने हैं या 1 स्टोरी सिलेक्ट करना है, तो वो कहाँ से करते हैं सर?
अच्छा अच्छा, so who is asking this question? Your name please.
सोबत खान सर।
Acha. So he's asking that during the modeling of our structure, I have used that you have to select 1 story or all stories. It is in the right corner of the ETAB. You can see my cursor, that is drop down menu of one story, all story on similar stories. We haven't used the similar stories command, but we will use this in the coming sessions. You will select it from here. For example, let me show it in 3D. Let me save it first. So for example, if you want to draw your structural members or column in one story, so you have to select one story from here that is in the right corner of the E tab. So if I click in here,
Okay, sir.
I have selected only one story. So you can see on the right window, only one column is constructed. But if I select all the stories and click somewhere here, so the column is constructed in all the stories. So this is the way how you construct your walls and beams and all other structural members in different stories, whether it is all stories or one story. If you want to delete something, you can also use this command.
Okay, sir. Okay.
Right? I have selected all
Okay.
stories and I select that and click in delete. So
Yes, sir.
all the members has been deleted.
सर आपने रिटेनिंग वॉल के लिए 3000 psi को डिफाइन किया और कॉलम के लिए 4000 psi को डिफाइन किया, लेकिन आपने 6000 सॉरी,
जी जी
लेकिन आपने डिज़ाइन में तो इस तरह किया, लेकिन प्रैक्टिकली जो हम कंस्ट्रक्शन करते हैं तो वो मैनुअलिटिकली होता है और उसमें एक ही रेशो इस्तेमाल होता है, या 3000 नॉर्मली जो है 1 2 4 या 3000 इस्तेमाल होता है, क्योंकि उसको अलग अलग करना है, क्योंकि रिटेनिंग वॉल और ये कॉलम जो है एक साथ इसके कंक्रीट होता है तो मुश्किल होता है कि अलग अलग इसकी कंक्रीट हो जाए ना, ये फिर इसके कॉलम की जो कॉलम है उसकी कैपेसिटी भी असर नहीं पड़ेगा सर?
देखिए, नॉर्मली जितने भी हमने प्रोजेक्ट्स किए, हाई राइज बिल्डिंग्स हमने किए, तो उसमें तो हमने जो रिटेनिंग वॉल है उसमें उतनी जरूरत नहीं होती कि आप FC प्राइम 6000 यूज करें, वो ऐसे इकोनॉमिकल बन जाते। ये यूज होते हैं, आपका जो अच्छा ठेकेदार होता है तो वो आपकी रिटेनिंग वॉल की अलग बेच बना देता है और कॉलम्स के लिए अलग बना देता है। कॉलम्स में कुछ जो मोनोलिथिक कंस्ट्रक्शन ऑफ जो उसमें रेनफोर्समेंट जा रही है रिटेनिंग वॉल की, वो 6000 की हो जाती है 2 3 4 फुट पे, और बाकी जितने भी लेंथ आपके पास, फॉर एग्जांपल एक लेंथ आपके पास 20 फीट है, तो उसमें अगर 2 3 फुट लेंथ की कंस्ट्रक्शन 6000 में आ जाए विथ मोनोलिथिकली इन कॉलम तो कोई फर्क नहीं, लेकिन बाकी अगर आप हिसाब कर लेते कितनी लेंथ बन रही, तो अगर आप उसको 6000 में करेंगे दैट वुड बिकम अनइकोनॉमिकल। ये कंट्रोल होते हैं।
ओके
जी जी बिल्कुल, ये फील्ड में होते हैं, लेकिन जब आपके पास लो राइज बिल्डिंग्स होती है तो उसमें फिर इंजीनियर्स आपके कॉलम्स में भी FC प्राइम इस तरह रखते हैं जो रिटेन वॉल उस कॉलम के सेम पे रखते हैं।
ओके सर, थैंक यू।
जी नमाज का टाइम भी हो रहा है, अगर किसी का क्वेश्चन है, इफ देयर इज एनी क्वेश्चन यू कैन आस्क इन इंग्लिश, इन उर्दू, इन पश्तो।
सर मेरा सवाल ये है कि जो स्टब कॉलम इस्तेमाल करते हैं उसके लिए किस तरह करेंगे? अगर 3rd 4th या 5th स्टोरी में स्टब कॉलम्स हैं और उसके साथ जो छज्जा एक्सट्रूड करते हैं, बाहर निकालते हैं 4 फीट तक, उनको कैसे डिजाइन करके?
समझ नहीं, कौन से कॉलम्स?
हाँ, स्टब कॉलम्स सर, जो मैंने ग्राउंड से निकलते जो 5th स्टोरी या 6 में अगर स्टब कॉलम आ जाते हैं।
आपका मतलब है कि वो जो कॉलम्स है वो फाउंडेशन से स्टार्ट नहीं होती, किसी स्टोरी से स्टार्ट होती है?
यस सर, जी जी।
उसको फ्लोटिंग कॉलम्स कहते हैं। आप फ्लोटिंग कॉलम्स की बात कर रहे हैं?
जी जी सर।
अच्छा, उसको उसको नॉर्मली डिजाइन नहीं किया जाता, क्योंकि अगर आप फॉर एग्जांपल आप उसमें अगर डिजाइन करना चाहे तो 3 4 स्टोरीज में तो कर सकते हैं, लेकिन हाई राइज बिल्डिंग में नहीं कर सकते, क्योंकि फॉर एग्जांपल आप देख सकते हैं, अगर ये आप 2 3 4 कॉलम्स है, अगर ये आप ग्राउंड फाउंडेशन से स्टार्ट ना करे और फर्स्ट स्टोरी 3rd स्टोरी से स्टार्ट करे या 2nd स्टोरी स्टार्ट करे और ये 10 और 12 स्टोरीज में जाए, तो इट विल रिक्वायर्स अ वेरी बिग डेप्थ ऑफ द बीम, क्योंकि इसका पंचिंग का इशू होगा। तो आपने अगर ब्रिज के गर्डर्स देखे होंगे, जिस तरह ये पिशावर BRT में बड़े बड़े गर्डर्स है, तो इस तरह की बीम सेक्शंस आपको रिक्वायर्ड होंगे टू resist that punching coming from that column। तो आप लो राइज स्टोरेज में तो कर सकते हैं, लेकिन हाई राइज स्टोरेज में ये रिकमेंडेड नहीं, ये अलाउ नहीं, स्ट्रक्चरल इंजीनियर अलाउ नहीं करेगा।
सर फ्रंट एलिवेशन में जो एक्सट्रूड करते हैं 4 फीट तक, तो उसको कैसे कंसीडर उसका लोड?
किस तरह एक्सट्रूड कर देते हैं, समझ नहीं आई।
सर जो ये छज्जास वगैरह होते हैं जो बालकनी वगैरह में जो एक्सट्रूड करते हैं ना सर।
स्लैब की बात कर रहे हैं?
जी जी सर।
हाँ, तो उस वो आप तो ले सकते हो। आप अगर आप अपने मॉडल में जो आपके पास जो बालकनीज है उसको अगर आप मॉडल ना भी करें तो इतना कोई फर्क नहीं पड़ता। और उसको आप अनसपोर्टेड अगर आप बीम ना निकाले तो 5 फीट 4 फीट तक आप जो जो बालकनीज है उसको आप ले सकते हैं। इस तरह कर लेते हैं कि नेक्स्ट टाइम इसमें हम बालकनीज भी ऐड कर लेंगे 2-2 3-3 फुट, ताकि आपको चीजें क्लियर हो जाए।
थैंक यू वेरी मच सर, थैंक यू।
सर ये जो मॉडलिंग है ना, जब हम मॉडलिंग करते हैं बीम की या स्लैब की या जो है ना रिटेनिंग वॉल की, जो बेसमेंट वॉल है, हम उसको लेफ्ट से राइट करें या राइट से लेफ्ट करें, मतलब इसकी जो लोकल एक्सिस है वो चेंज हो सकती है। अगर वो चेंज हो सकती है तो इसके रिजल्ट पर असर होगा कि नहीं?
तो आप दोबारा चेक कर रहे हैं लोकल एक्सिस को, आप रिवर्स कर सकते हैं ना। आप
जी
लोड
सर, वो
लगाने
तो
से पहले लोकल एक्सिस को चेक करेंगे, उसकी डायरेक्शन क्या है, उसके मुताबिक फिर आप लोड्स लगाएंगे। इस तरह तो नहीं
नहीं
करेंगे
सर।
कि कुछ
जी
वॉल्स
जी।
की लोकल एक्सिस बाहर है कुछ के अंदर है और आप लोकल 3 एक्सिस में लोड्स लगा ले, तो फिर तो रिजल्ट खामखा डिफरेंट होगी।
सर बीम की चेंज हो सकती है कि नहीं मॉडलिंग के, अगर कोई लेफ्ट से राइट से करे और दूसरा जो है राइट से लेफ्ट करे, तो बीम की चेंज हो सकती है कि नहीं?
हाँ, वो तो आपके पास ओरिएंटेशन भी डिपेंड करता है, वो आप चेक कर सकते हो, उसको आप रिवर्स भी कर सकते हो, इतना बड़ा इशू नहीं है।
ओके सर, थैंक यू सर।
ठीक है जी। 2 मिनट रहते हैं, अगर कोई क्वेश्चन है, इफ देयर एनी क्वेश्चन यू कैन आस्क।
सर ये स्लाइड हमारे साथ शेयर कर ले, वो स्लाइड
जी जी, ये प्रेजेंटेशन मैं आपके साथ शेयर कर लूंगा।
सेशन 3 और 2 पे भी सर शेयर करते हैं।
ये कौन कह रहा है जी?
मैं शाहिद सर।
आपके साथ शेयर नहीं हुई?
और सिर्फ 1 शेयर हुआ है सर, वो सेशन 1 स्लाइड जो है ना।
आप काइंडली मुझे
2 और
पर्सनली
3
व्हाट्सएप पे
और
मैसेज कर रिमाइंड दे दे मुझे, रिमाइंडर तो मैं आपके साथ शेयर कर लूंगा अभी।
सही, थैंक यू
ठीक है।
सर।
अस्सलाम वालेकुम सर।
वालेकुम
सर
अस्सलाम।
आज मेरा पहला लेक्चर था और ये ऑटोकैड ड्राइंग जो है ये मिल सकती है मुझे?
आप अब्बास खान है?
यस सर।
अच्छा, आपको मुझे टेक्स्ट कर दे, मैं आपको एक साथ शेयर कर लूंगा कैट फाइल।
ओके जी, थैंक यू सर।
सो अगर कोई क्वेश्चन नहीं है तो बस एंड को इसको सेशन को एंड करते हैं। इफ देयर एनी क्वेश्चन यू कैन नोट डाउन एंड यू कैन आस्क मी टुमारो एज वेल, राइट?
ओके सर, थैंक यू सर।
ओके सर, थैंक यू।
इट वाज नाइस मीटिंग यू ऑल ऑफ, थैंक यू।
ओके, थैंक
अल्लाह
यू
हाफिज।
सर।
Okay, sir. Thank you. Allah.